Good day all of you. In this class, I want to explain the transfer ratio or transfer gain of the feedback amplifier. Transfer ratio or transfer gain. Okay. Is to derive the transfer ratio or transfer gain of a feedback amplifier, we need to draw a small block diagram. The block diagram consists of your basic amplifier of gain A, okay, the feedback network, of factor beta, okay, then this is the load resistor across which we are going to collect our output. Let the output be X naught. In general, let the output be X naught, and we are connecting a part of output to the feedback network, and here you have a mixer network, okay, and from this side you are going to give the signal Xs, and from the feedback you are going to mix another signal Xf, the feedback signal. After mixing Xs and Xf, you are going to get Xi. Okay. So this is your X naught. So this is the block diagram from which we are going to derive transfer ratio or transfer gain. Okay. So see here, Xi. Xi is the output of your mixer. Yes, this mixer is mixing Xs and Xf. Yes, Xi expression is, so if you write the Xi expression, Xi is equal to Xs plus or minus Xf. Okay, Xs plus or minus Xf. In the last class, I told you that the feedback is of two types, positive feedback and negative feedback. That is depending on the phases of your Xs and Xf. If Xs and Xf are in same phase, then the feedback is said to be positive feedback. And if Xs and Xf are in opposite phase, the feedback is said to be negative. Okay. So now we'll derive the transfer ratio or transfer gain for the positive feedback and for the negative feedback separately. Okay. See, for the basic amplifier, the gain is A. So this gain is called gain without feedback. Now we are going to derive the gain with feedback of this feedback amplifier. That is nothing but your transfer ratio or transfer gain. Okay. So now we'll start the transfer ratio or transfer gain for positive feedback. Okay. Yes, for positive feedback, yes, Xs and Xf are in same phase. Okay. And so the Xs and Xf are in same phase. What about your Xi? Xi is equal to Xs plus Xf. Okay. Now, the gain with feedback or transfer ratio with feedback is represented by AF, and AF is equal to X naught by Xs. Okay. See, what is this gain A? It is the gain of the amplifier without feedback. What does this say? Formula for A. What is the output of the amplifier?
X naught. Okay, what is the input of the amplifier? Xi. So what is gain? Output by input. So X naught by Xi. This is for the basic amplifier. But for the entire feedback amplifier, and if you consider the feedback as positive feedback, then for the entire feedback amplifier, this is the output voltage and this is the input voltage. That is the reason the gain with feedback or transfer ratio with feedback is AF, that is equal to X naught by XS. Okay. So X naught by,
what is XS? XS is Xi minus XF. So Xi minus XF. Okay. Now divide the numerator and denominator with the Xi. Okay. So if you divide the numerator and denominator with Xi, X naught by Xi, Xi by Xi becomes 1. So 1 minus XF by Xi. Okay. So now if we see, what is X naught by Xi? X naught by Xi is nothing but your A. So A by 1 minus, you can write XF by Xi as XF by X naught into X naught by Xi. Okay. Then, yes, you can write it as A by 1 minus, what is XF by X naught? See here, it is the feedback network. For the feedback network, what is the input? Input is X naught. From the feedback network, what is the output? Output is XF. So what is XF? XF is nothing but beta into X naught. So what is this XF by X naught? If you go for XF by X naught, is nothing but your beta. So this is XF by X naught is beta and X naught by Xi is A. So what is totally? It is A by 1 minus A beta. So it implies for the positive feedback, what is AF? AF is nothing but A by 1 minus A beta. Okay. So that is the transfer ratio or transfer gain, or I can call it as gain with the feedback in the case of positive feedback. Okay. We know for the positive feedback all the time is loop by loop or cycle by cycle, output is increasing. So as the output is increasing, gain is increasing. Okay. So AF is the gain with feedback and A is gain without feedback. So in the case of positive feedback, as the gain is increasing cycle by cycle, we can say mod AF is always greater than mod A. Mod AF is always greater than mod A. Okay. Another point, yes, another point. Suppose if this mod A beta is equal to 1. What is this mod A beta? Yes, A beta is called, yes, A beta is called loop gain. A beta is called loop gain. Why it is called loop gain? See here, this is a loop. For this loop, this is called forward path and this is called reverse path. Okay. So in the forward path, the gain is A and in the reverse path, the gain is beta. So totally for the loop, what is the gain? A into beta. So that is the reason A beta is called loop gain. So if loop gain is 1, what will happen? So if you substitute this mod A beta is equal to 1 in this expression, so what is happening? AF becomes, yes, it implies AF is, yes, say here, 1 minus 1 in the denominator, you are going to get 0. So it is A by 0 is nothing but infinite. Gain with feedback is infinite, means amplifier goes into unstable state. If the amplifier goes into unstable state, what will happen? Output will not be constant and the noise increases, distortion increases and the bandwidth decreases. Okay, so that is the reason of not using positive feedback in the case of amplifier circuits. Okay, but where the positive feedback is used, I already told you the positive feedback is used in oscillators. Okay, so this is about your positive feedback. Okay, now I'll derive the same expression for negative feedback. Now for the negative feedback, yes, for the negative feedback we know XS and XF are in opposite phase. So what will happen? Your Xi becomes XS minus XF. XS minus XF. So same way AF, gain with feedback, is equal to X naught by XS. So it is X naught by, what is XS? Xi plus XF. So Xi plus Xf. Okay. So in the same way here also, yes, you divide the numerator and denominator with Xi. So what will happen? X0 by Xi by 1 plus Xf by Xi. So you can write it as A by 1 plus Xf by X0 into X0 by Xi. Okay. Yes. So you get A by 1 plus, what is Xf by X0? Already I told you it is beta. So what is X0 by Xi? A. So in the case of negative feedback, what is your AF? AF is nothing but A by 1 plus A beta. Okay. So this is the expression for gain with negative feedback, or the transfer ratio or transfer gain of a negative feedback circuit or negative feedback amplifier. Okay, so here another important point is always your mod AF is less than mod A. What is the reason? Why always the gain is less than the gain without feedback? Because of negative feedback all the time. Yes, see here, your input is decreasing by Xf times. Okay, so all the time loop by loop, your input decreases, so output decreases, the gain decreases. Okay, the another point is, suppose if your loop gain is far greater than 1, loop gain is far greater than 1. What will happen if loop gain is far greater than 1? Yes, see here, yes, if it is far greater than 1, your AF is A by A beta is nothing but 1 by beta. So if you see these two, your AF is completely depending on the beta network. And I already told you, the beta network of an amplifier consists of only resistive elements. And you know, the resistors are very stable and they won't change with respect to the temperature or with respect to the surroundings, with respect to the potentials. They won't change as the resistors are very stable. And I can say in the negative feedback concept, the gain is very stable because the gain is depending on your feedback network. Okay, so this is about your negative feedback amplifier, and this is the expression for the gain with feedback or the transfer ratio. Okay, so in the case of positive feedback, the same expression is AF is equal to A by 1 minus A beta. And whenever the loop gain is equal to 1, there you are going to get instability. Okay, and the positive feedback is used in oscillators. But when this loop gain is greater than 1 in the case of negative feedback, yes, the gain is depending on only the feedback network, which is of resistive, so which is very stable. Okay, so that is the reason this negative feedback is used in amplifiers. Okay, so totally this negative feedback is used in amplifiers. Okay, so yes, in this unit the amplifiers are with negative feedback, and we are going to stress only on the negative feedback, and in the future classes and the future concepts like oscillators, we are going to use the positive feedback. Okay, now I will explain what are the effects of negative feedback. Okay, yes. So now I will explain the effects of negative feedback. I will explain the effects in terms of advantages and disadvantages. Okay. So the concept is effects of negative feedback in amplifiers. Okay. So first I'll tell you about the advantages. Yes. The first and foremost advantage of negative feedback in amplifiers is you'll get stability in gain. Stability in gain. And the second point, yes, it increases the bandwidth. Okay, and the third point is decreases the noise and distortion. Okay, and the fourth point modifies the input and
amplifier according to our requirement. Okay, so these are the main advantages of your negative feedback. What is the disadvantage? Yes, what is the disadvantage? The one and only disadvantage of negative feedback amplifier is, yes, it reduces the gain. This is the one and only disadvantage. Okay? Yes. Though the gain is reduced if we use negative feedback, why are we using negative feedback in amplifiers? Because of all these advantages. Okay? And designing a feedback amplifier circuit, you have to design for your required gain. Yes. At the same time, you're going to get all these advantages. Okay? So in the next class, I want to explain all these advantages in detail. Okay, thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.